So welcome to Managing Windows Devices with Microsoft Endpoint Manager. My name is Mike Niehaus. I'm a Principal Program Manager on the Windows Autopilot team.
I am Mizanur Rahman, Senior Program Manager at Windows Autopilot team.
So as part of this session, we want to talk about managing Windows 10 devices, whether on-prem or in the cloud, key features that we have available for managing devices from the cloud, how we can do this remotely, how we can provision devices using Windows Autopilot, and how we can provision those devices remotely. With that, let's jump in. All of this, including Windows Autopilot, Intune, Configuration Manager, all of these are part of the Microsoft Endpoint Manager product. They provide together comprehensive management capabilities for all your physical and virtual endpoints. This includes the initial provisioning of those endpoints as well as the continued management of them. We're going to focus in this session on Windows devices, talking about the capabilities in Microsoft Endpoint Manager that cover the entire life cycle of the Windows device. Key capabilities include deployment and management of apps, application of security policies, management of security and conditional access checks, configuration of the OS and app-related settings, installation of Windows 10 feature and quality updates, and configuration of VPN and Wi-Fi connections. When we look at this as part of a continuum, we can see that there's two ends of the spectrum. You can have an entirely on-premises infrastructure, or you could move entirely to the cloud. It's up to you. A lot of customers have people working remotely, while many are transitioning to a more hybrid workforce, where some days they're in the office and other days they're at home. So having management purely on premises really isn't sufficient anymore. So we are seeing customers shift toward a co-management environment with Config Manager and Intune working together to manage a device, even when it's not connected to the corporate network. In some cases, they may go all the way to a cloud native environment and eliminate all on-premises infrastructure for managing those Windows 10 devices altogether. Azure Active Directory join, having devices joined to your cloud tenant instead of requiring them to connect back to your on-premises Active Directory, is a key capability as we shift more toward the cloud. It was designed from the start for devices that are only connected to the internet, avoiding many of the complexities of Active Directory that often require VPN connectivity for ongoing use. If you haven't tried out Azure AD Join, there's no time like the present. Of course, you can use hybrid Azure AD Join if you must. That takes an Active Directory join device with all of its complexities, registers it into your cloud tenant to enable additional functionality such as authenticating to cloud resources, including Intune, OneDrive, Outlook, etc. But it is still at its core an Active Directory join device. It still needs connectivity to the corporate network. It still needs to be able to talk to Active Directory domain controllers. We'll talk about all of these scenarios more as we dig deeper. First, let's dig deeper into each of the cloud-based feature areas, starting with Win32 apps. With the availability of the Intune management extensions, the ability to install Win32 apps of any kind was made available in Intune. Since then, a number of additional enhancements have been added, including specifying that the app requires a reboot either immediately or when convenient, based on the return code from that app. You can specify dependencies, so any apps that need to be installed first before this app is installed. You can monitor and track these Win32 apps as part of the Windows Autopilot enrollment status page. You can do peer-to-peer content sharing or server-based caching using delivery optimization and the Microsoft Connected Cache. So all of these provide a good set of capabilities for delivering Win32 apps. Soon we'll also be adding the ability to leverage supersedence to make it easier to manage app updates. Security is obviously a major concern as well. To make it as simple as possible to adopt recommended security settings for Windows 10 and Microsoft Edge, security baselines have been implemented that you can leverage as is or tweak for your specific requirements. Either way, you know that you're starting from a set of industry-based recommendations that are kept up to date as Windows and Edge are updated. While many settings are available natively in Windows via MDM, and that list grows with each Windows 10 release, there are thousands more that exist via group policy. The administrative templates feature in Intune adds support for all of these so that these GPO settings can be configured directly from the cloud, leveraging the same ADMX policy definition files that have been used for years with the group policy editor. In fact, we just added another 646 settings that weren't previously available, leveraging that GPO engine to configure those settings directly on the devices. Soon, this administrative templates feature will also support adding your own ADMX files too, whether using the ones provided by a third-party ISV or ones that you've authored yourself. We're also working on a simplified authoring experience for all Windows policy settings, which should help make individual settings much easier to find and make it easier to create your administrative profile templates to configure your devices. When it comes to updating Windows, one of the biggest enhancements that you might not have noticed is the ability to explicitly target Windows 10 feature updates to groups of devices. No need to worry about deferral periods anymore. You just create groups for your initial validation rings and your staged broad rollout, and Intune will take care of the rest. This is done through coordination between Intune and a component of Windows Update called the Deployment Scheduling Service. Intune can tell it exactly when a particular feature update should be deployed. So that gives you complete control over the feature update deployment process. For those who need to be able to easily connect from home or to other remote locations back into the corporate network using always-on VPN, it was always challenging to define VPN profiles if you were doing machine tunnels, as there was no easy way to do that through Intune. Since that's required for hybrid Azure AD join scenarios where you want to enable a remote device to connect back into the corporate network, we've made sure that we can do this more easily. So you can go into Intune, create a VPN profile, specify that it's a machine tunnel, specify all the needed IKE v2 settings for that connection profile, and even the device certificate that should be used for authenticating the device to the always-on VPN server. So all of that gets bundled up into a simple VPN device configuration profile. Co-management has been around for a while, and it's continuing to be enhanced to make it easier to deploy and configure. We're working on adding an additional co-management profile in Intune that lets you specify whether Intune or Config Manager should control who is authoritative for the different co-management workloads. We're also going to simplify the Config Manager agent installation process for scenarios where we start from Intune and then deploy the Config Manager agent, for example, an Autopilot scenario. Notice too that you can specify a task sequence that should be automatically executed when the Config Manager agent installs via the provision TS parameter. Using this setting, you can do all of your Windows configuration tasks via a Config Manager task sequence and integrate that task sequence into the Windows Autopilot enrollment status page, blocking access to the desktop until the task sequence has completed its configuration, making sure Windows is secure and customized as desired before the user can access the desktop. So those are some of the key building blocks for managing Windows 10 devices from the cloud, using either Intune by itself or Intune plus Config Manager via co-management. Naturally, these same building blocks are used as part of the new device provisioning process, which we call Windows Autopilot. For more on Windows Autopilot, let me hand it over to my teammate, Ms.
Thank you, Michael. Hello, everyone. Now let's talk about Windows Autopilot. For the next few minutes, I'll walk you through some of the new features that we have released recently and also give you a sneak peek to some of the awesome upcoming features. But before I start, for anyone who doesn't know what Autopilot is, let me give you a quick intro on Windows Autopilot. So what is Windows Autopilot? We have this traditional way of deploying Windows devices, which requires organization to build a custom image by gathering everything you need, like an apps, drivers, policies, and settings into a single image and deploy them into a device. Overall, that process takes a lot of time and effort for IT and organization, which turns into cost. To overcome this, we have this modern deployment solution that helps organization and IT to deploy an unboxed shrink-wrapped device to their end user. When the end user or employee of that organization powers on that device, they have this simple device setup experience with very minimal decision-making steps. During this provisioning, the device implements all required apps and policies from Microsoft Endpoint Manager to the power of cloud. So, in summary, Windows Autopilot is the cloud-based solution that simplifies device deployment and device setup experiences, or OB, by reducing the overall time and cost for the organization to deploy and manage Win 10 devices. You can always learn more about Windows Autopilot at aka.ms/Windows Autopilot. Now, let me start with some of the features we have recently released with our goal to simplify the device deployment and management experiences. First, let's talk about Autopilot user-driven mode for a hybrid Azure AD join. In this deployment method, you can deploy devices to join Azure AD remotely and enroll into an MDM. Recently, we have released this feature where you can deploy over VPN feature. With Windows 19.03 and above, you can now use always-on VPN or any other third-party VPN client you have that have support logon integration or auto connection, similar to what Michael was going over earlier. Next one is Windows Autopilot white glove deployment. In this process, the white glove partners or the IT staff can pre-provision a Win 10 device to be fully configured and business ready for an organization or their users. Currently, this is in a preview, and we are targeting for general availability, sometimes calendar year 2020. The next one we have is Autopilot self-deployment mode. With this deployment method, the device would deploy without the need of any user credentials, automatically join Azure AD and MDM enroll. Currently, this is also in preview, and we are targeting for a general availability, same calendar year 2020. But we have not stopped there. We took Autopilot to its next phase and brought Autopilot deployment to Windows Holographic OS. With Windows Holographic 2004 and above, you can deploy HoloLens devices with Windows Autopilot self-deployment mode. Soon, we'll be launching two other new features in this area: Wi-Fi support during Autopilot deployment for HoloLens and Autopilot tenant lock for HoloLens 2 devices. The next feature I would like to call out is Windows Autopilot Update. This is a capability where we can do fixes, bug fixes, or a feature update to an Autopilot client with using Windows Update. With this capability, you do not need to update your OS or reimage to get the latest fix of the features. Very soon, we'll be publishing an Autopilot update through this channel. Now, if you look at some other enhancement we have done in this area is our enrollment status page, for example, which we also call it ESP, which allows you to track apps, policies, certificates, etc. to be deployed during deployment. Recently, we have enabled device level targeting for ESP. Also soon, you'll be able to monitor task sequence for co-management during ESP. Michael referenced about that a few slides earlier. The next set of features we are a lot investing on is called the deployment reporting and monitoring. In that area, we have tons of enhancement going on. We have recently released Windows Autopilot Deployment Reporting Endpoint Manager, which is currently in preview, and we're making tons of improvement in that reporting space to provide you more accurate deployment results and empower you to troubleshoot any issues during deployment. Very soon, you'll be able to see ESP duration broken down at devices and user targeted level, and app installation status. Policy status tracking is also part of our roadmap to support in that deployment report. In addition to it, we're also working on a client-side diagnostic view and troubleshooting capability, which would allow you to see deployment issues with a very simple and organized view on a Win 10 client. And finally, we have the DFCI management through Endpoint Manager. For your Autopilot deployed devices, DFCI will allow you to manage device firmware settings through the Endpoint Manager. Currently, this is only available with Surface devices, but we are actively working with other OEMs to make it available for the devices. General availability, it's targeted calendar year 20, and we also have plans to support some additional capabilities in the firmware management area. Now I'll give you a sneak peek about a couple of upcoming Autopilot features. But first, let's look at a little bit more on the Autopilot client-side diagnostic and telemetry. If you have deployed devices using Windows Autopilot, you must have seen an error like this. Sometimes some error doesn't provide much clarity on the issues, and we tend to ask you to do a Shift F10 and run diagnostic script and look at the logs. Even there, sometimes it could be too many log files that it might be confusing to know what to look at. We are working to solve this problem for you and make it simple enough to diagnose and troubleshoot deployment on a Win 10 client. When you run into an error like this during the ESP or any other point during UBI, you will have an option on the left side of the screen called View Diagnostic. And when you click on it, it will launch a view which will provide you details about the deployment issues and many other important information related to the deployment. Not only here, for any error cases only, but you can launch this diagnostic view from any point of your device setup process during UBI. You just press Ctrl-Alt-D and it will launch the diagnostic view for you. Here's another example where this diagnostic view will be very helpful, which is the technician flow of the Windows white glove, Autopilot white glove deployment. And again, as I mentioned, it's not only here. Anywhere you launch, you can have this diagnostic view at your fingertips, just pressing Ctrl-Alt-D, and it will launch the diagnostic view for you. Now let's look at when you click on that, what happens when you click on the view diagnostic? So when you click on the view diagnostic, what's going to happen is you're going to be seeing 3 categories of information. During this process, your device will collect a lot of the log information behind you on behalf of you, and you'll be landing on this center pivot, which is called the deployment info, which should be the middle one, and it will provide you an organized and visualized in a much user-friendly and subcategorized form. On the right, you have apps and policies, which would show you apps and policy status. And finally, on the left, you have the configuration info, which would provide you details about some of the device information, about Autopilot profile information, and other deployment related configuration. We'll go over a little bit, a few slides down about this more. The goal of this feature is to empower you to be able to diagnose and troubleshoot deployment issues when needed. Now, let me give you a sneak peek to this flow on what it might look like. Now, I would like to caution that we're actively building this feature now. So I'm going to show you is a click through on the user interactions. But again, because it's a product we're developing, there are a few things which might change on the UI when this final product releases. So if you look at this error during ESP, and it's, for example, and you have this view diagnostic show up when there's an error happening. Now, when you click on it, the device will run the process behind you to collect all the required logs and present them into a 3 categorized view. The deployment info tab will be the center one, and that's where you're going to land. And the device's information are going to be categorized into multiple categories. For example, the connectivity check, what happened during the Autopilot flow, what happened during the enrollment status, and also Windows security. You can also change this view to a timeline view from the top. So if you click on it, the timeline view will represent all the events into a sequence of events from the beginning of the UBI. On the right, you have the apps installation and policy status. It's going to give you the time it took and the installation status or any error related to apps or policies. On the left, you have the configuration info, which will show you information about the device you have, and also about the Autopilot profile it collected from the cloud. The MDM, the ADJ enrollment status with IDs, and various other important information, which will help you to troubleshoot. When you want to export the log, you can do so by clicking on the export log and selecting your choice of your folder where you want to save the log. When done, you'll be back to the diagnostic view, and you can close your view and return to the UBI step where you originally started it from. I would like to iterate that this is an illustration purpose only, but some of the actual product UI may vary. We are very excited about this feature, and I hope you all are too. But now I'm going to go shift gear a little bit to a new Autopilot feature and capabilities that we have recently released in a private preview, and soon it's going to be generally available in this calendar year. And that feature is Windows Autopilot for HoloLens 2 devices. As adoption of HoloLens 2 is increasing with our various industries and business segments, we have found that deploying this type of devices at scale is very challenging, time-consuming, and end of the day could turn into costly. Imagine an IT admin putting on a HoloLens device, calibrating the device, and moving through this decision-making step during the UBI, such as user ID and password, to join the device into the tenant. Now repeat that process for many devices they need to deploy in their organization. Yes, it is painful. To simplify that steps for organization and IT, we have built Windows Autopilot for a HoloLens device. Windows Autopilot for a HoloLens with Microsoft Endpoint Manager simplifies the deployment, streamlines the device's security and management, driving significant cost and time savings for your organization. As part of this modern deployment story, we looked and redesigned a lot of the Windows holographic OS device setup flow to give IT and end user a simple and personalized provisioning flow. To deploy a HoloLens 2 devices with Autopilot, first your organization must meet Windows Autopilot licensing and networking requirements. Second, you would need to register your Windows Autopilot HoloLens devices. Your HoloLens devices must have version Windows holographic OS 2004 or above. If you don't have it, you can update your HoloLens 2 devices using the Advanced Recovery Companion app, which you can download from the Microsoft Store. Now, on the registration phase of it, as I said, you can actually register these devices very similar to your PC. Your partners or your reseller can register these devices using PKID or device tuple. HoloLens has a similar capability as PC. Or you can also self-serve and register themselves by using hardware hash using Microsoft Endpoint Manager. Now, after that, when you're done registering, the next step would be for you to configure in a self-deployment mode profile and assign it to your HoloLens devices group. And during that configuration, you can select a customized language which is available and region that is supported by HoloLens 2 device. You can also set your device name for those devices so that it changes the device name before the device joins an Azure AD. You need to configure an ESP also for your HoloLens devices. And finally, when you're done, you can connect that device to the internet and deploy. Now, what I'm going to show you a video of what if this provisioning flow would look like after all this configuration is done and your organization or IT connects this device to the internet and deploys. We actually deployed this HoloLens devices remotely at our home. After the device is powered on and got connected, a HoloLens device will connect to the internet and get Autopilot profile. After collecting the Autopilot profile, you'll see that the company branding page will show up, which is a signature image from Windows Autopilot self-deployment mode. Behind the scene, the device has skipped a bunch of UBI pages and already set up various configurations set by the IT admin. During this period, the device would set up device name and do a reboot to apply the device name. Post reboot, you'll be seeing an enrollment status page. At first step, the device will be completing its TPM attestation, join Azure AD, and enroll to MDM. Post enrollment, you'll start applying policies, certs, and installing apps to the devices that is targeted by your IT admin or organization and through the Microsoft Endpoint Manager. When done, the device will automatically reboot one more time and then land to the user sign-in screen. Now, the device is ready and secured for an employee of that organization to sign in and use. And you can see there are multiple methods of signing in with an HoloLens device. Now, if you see that overall experience, this deployment was such a simple deployment with absolutely zero touch from an IT admin. IT admin can deploy multiple of these devices at the same time without needing to putting this device over their head. Obviously, they will need a USB-C to an Ethernet adapter dongle to be connected to the device. Now, we have also solved that problem too. So during the provisioning, as I explained, the device have done all these steps. But then when the device is ready for an end employee or a first-time user to use, what happens during that flow? So here, Nicole, an employee of that organization, as a first-time user, picks up any HoloLens devices which was provisioned by Windows Autopilot. She takes it on, puts it on, and then sign on with her own credentials and other auth methods which is supported by the device. Goes through her own user personalization, learns about various gestures, and finally land into a start menu. A simple, end-user focused, and a zero complexity device setup experience. So Autopilot self-deployment for HoloLens 2 is currently available in private preview with partners or reseller support in registering these devices, similar way as PC. HoloLens 2 devices soon will be shipping with PKID barcode outside of the box for partners like reseller to register these devices easily for their customers. This feature would soon be in public preview and finally generally available by end of calendar year 2020. Now, there are two new features I would like to call out what's coming out next. So first is the Wi-Fi support. Remember I mentioned that you would need a USB-C dongle to connect this device to the internet. This is the one. If you need to deploy these devices over Wi-Fi, you have the support now. So it is currently under the Insider's build. So with this new update, you can actually have a Wi-Fi support during your Autopilot provisioning flow. And then the next feature we have is called the full tenant lockdown for Autopilot deployed devices. This only happens after the first time the device gets enrolled and you set up a policy using an OMA URI settings. After first enrollment, any future reset or reimage would require a mandatory network and the device must be deployed with Autopilot to the same tenant. In addition, there will be no local or Azure AD join using PPKG to prevent any escape hatch during the device setup process. So this makes sure that an organization enrolled devices must be state enrolled to the same tenant. And there is no escape hatch during the setup for a user to bypass that. That's Windows Autopilot HoloLens. Now, there's another thing about the remote provisioning, right? We have looked into so many options to provision your device. And during the times like this, if we have to remote provision your device, your Azure AD is your best option to deploy these devices for your organization. But if you're not there yet, alternatively, you can do hybrid Azure AD join with skipping connectivity check. With Windows 1903 and above, we have now, you can always use always on VPN or any other third-party VPN to get your connection. But pretty much wherever you are, you can do this provisioning of your devices in a much simpler and a cost-effective way through Microsoft Endpoint Manager. Now that's the end of Autopilot. Now at the end we are very much into our presentation. There are some few key takeaways I would like to mention towards the end. Wherever you are in your cloud management story, whether you are still thinking about to move to the Intune, or you have started with co-management, or you are completely on the cloud, use Microsoft Endpoint Manager. It is truly your hub to unify security, apps, access, compliance, and end-user experience across your entire technology state. And because it can leverage Microsoft's powerful data set, it is also intelligent. delivering analytics and signals to keep you ahead of the change so that you can keep your costs down and keep your organization running smoothly to the whatever the future brings. And we believe partners are key to the success, and Endpoint Manager is also the integration point for the ecosystem. We also mentioned that there are so many other learning sessions in this Ignite, and this is just the beginning. You will find these and more at our video hub at aka.ms/Microsoft Ignite 2020/MEM. If you have missed Brad Anderson's live session or any other here, please make sure you catch them as well. Now, we have dozens of demos and step-by-step, as I mentioned earlier. I mean, from Windows Autopilot to virtual desktop, from endpoint security management to Microsoft Tunnel, or to endpoint analytics and universal print. To access those, visit aka.ms/Microsoft Ignite 2020/MEM. We will see you there. Thank you.